Hello students, by this video let us study about the unit 4 transition and inner transition elements. So here we are going to see about the introduction in the transition elements. So once we complete the understanding of this transition elements, then we go to the inner transition elements. So looking to the introductory part of this transition element, what are transition elements? So that's what we are going to study now. So transition elements, when you look into the periodic table, extreme right end of the periodic table is your P block elements and extreme left side of the periodic table is your S block element, and at the bottom part of the periodic table is your F block element, and the D block elements comes in the center of the periodic table. So these D block elements are called as transition elements. So in the periodic table, transition elements position is in between S block elements and the P block elements, right? So those elements in the periodic table are called as transition elements. So based on the periodic table position, the chemical properties and size of the elements, this transition elements is having a particular position in the periodic table, that is the central position in the periodic table. Okay, so when compared to the size of the elements in the periodic table of S block and P block, the size of the D block element, that is the transition elements, they will be always less than that of the size of the S block element, and when compared to the P block element size, the transition elements will be always having the size less than that of the P block elements. So that's why in between S block and P block elements, this D block elements come, and these D block elements are nothing but your transition elements. Okay, so according to IUPAC name, there is particular definition for these D block elements. So what is that definition? So according to IUPAC, transition metals are defined as the metals which have incomplete d subshell, yes, either in the neutral atom or in the ionic state. So what is IUPAC definition for transition metals? So transition metals, they are the metals which are having incomplete d subshell. That means the d subshells are incomplete either in their neutral atom state or in the ionic state. Okay, then these transition metals, they are all D block elements. The transition metals all are D block. They are placed in the D block of the periodic table. So they are D block elements. But all D block elements are not transition. Yes. So there are some elements in the D block which does not obey this IUPAC definition, which is not going according to the IUPAC definition, which does not have incomplete D subshells. Yes. So there are some metals in the D block which are not transition, metal. So we will see regarding that in the upcoming video. So which elements does not show this act as a non-transition metal. So that we will see later on. Then that means from this point you should understand that all D block elements are not transition, but all transition metals are D block elements. Fine. Now when we are looking into the periodic table, I said already the transition metals, they always occupy the center position of the periodic table. Now looking into the group wise, the group number, what are the groups included in the periodic table, in the transition metals in the periodic table? So they are group number 3 to group number 12. Group number 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, so these many groups are consist of D block transition elements, group number 3 to group number 12. Okay, so if you look into the periodic table given in your textbook, you can easily find out the transition element. So transition element starts from the group number 3 and it ends in group number 12. So in between from 3 to 12, all these elements in these groups are your transition elements. Now we are looking into the period wise. The transition element starts from the 4th period and ends till 7th period. So 4th period, 5th Okay, so they are d block transition elements. Understanding? Clear? So in d block elements, we call these d block elements as transition elements because the d subshell is incomplete, right? Now here in d block elements, the last electron in the d block elements, the atoms, the last electron will always enter into the d orbitals of penultimate shell. Okay, so this point is very important. In the transition elements, the atoms of these transition elements, the last electron, where does it enter? It enters into the d orbitals of the penultimate shell. Of course, we tell the elements, we separate the elements in the periodic table like S block, P block, D block, F block. Why do we represent it like blocks? Because the last valence shell electron, if it enters into the S block, S subshell or S orbital, then we call it as S block elements. If the valence electron enters into the P subshell or P orbital, then it is P block elements. Okay, now if the last electron, so the valence shell electron entered into the F subshell or orbital, then we call it F block element. Likewise here also, the last shell, the valence electron, the valence electron present the last shell, that valence shell electron, they enter into the subshell, so it is called as d block elements. Of course, that is right. But in this d orbital or the d subshell, the valence electron enters into penultimate shell. It enters into the penultimate shell. Now we have to understand what is penultimate shell. So here you can see I have drawn the representation of an atom here. Yes. So the center is the nucleus. Surrounding the nucleus is the shells. First shell, second shell, last shell. Okay. So as the atomic number increases, the shell number also increases. That we know very well. Okay. So the last shell we call it as nth shell. Nth shell. Okay. So last but one, that is n minus 1 shell. Okay. Last shell, the last shell we call it as nth shell. So in the last shell we get electrons will be there. So those electrons are called as valence electron. So this last shell, that is nth shell, that we call it as ultimate. We call it as ultimate shell. Ultimate because it is the last one. Okay. So that's why we call it the ultimate shell. So last but one. So the shell before the nth shell. Last but one, that is your n minus 1. N minus 1. Okay. So that is your penultimate shell. They are called as penultimate shell. So in this d block elements, that is in the transition elements, the valence electron, this electron enters into the d orbital of the penultimate shell. Okay. Then, so based on this, again the transition elements are again classified into series. First transition series, second transition series, third transition series, and fourth transition series. Okay. So the first transition series. So when we know that when we consider the period, yes, transition elements are from the 4th period till 7th period. Okay, period wise when we are looking into the periodic table, the transition element position is from the 4th period till 7th period. Okay, so based on that, the first transition series, they are called as 3D transition series. 3D transition series. So in the first transition series, what are the elements? Starting from scandium to zinc. Scandium atomic number 21. Up to zinc atomic number 30. So 21 to 30, those elements starting from scandium to zinc, so they are the first transition series or also called as 3D series. Also called as 3D series. Okay. So the 3D series starts from the 4th period. 4th period. Okay. So 4 minus 1, so that gives you 3D series. So 3D series is your first transition series which belongs to the 4th period. Okay. So 4 minus 1, that gives you 3D. So it is a technique to remember the series name. So 4th period is your first transition series. So it's also called as 3D series. Why it is called as 3D series? Because the last electron enters into the d orbital of the penultimate shell. So n is your Principal quadrant number n. Yes, so n minus 1. So here if n is equal to 4, then 3D means we got 4 minus 1. That is 4 minus 1, that is your 3D. Okay, 3D. Now, the second transition series, so that is your 4D series. So second transition series that comes in the fifth period. So you can consider like 5 minus 1, 4. So 4D series. So last electron enter into the 4D orbital. Yes, that is your of the penultimate shell. So okay, so it is 4D series also. So for the 4D series, the element starts from yttrium atomic number 39 up to cadmium atomic number 48. So these many elements are your second transition series elements starting from yttrium to cadmium. Okay, next comes the third transition series. So third transition series comes under the period, sixth period. Yes, all these elements comes in 6th period. So this is also called as 5D series. This is also called as 5D series. Okay. So 6 minus 1. So 5D 5D series. Okay. So in the 5D series, that is your third transition series. The element starts from lanthanum, atomic number 57. Yes, and after atomic number 57, then comes the hafnium. Hafnium starts from is 72 atomic number. So there is a breakup here. Okay. So after lanthanum 57, then comes the next element, atomic number 58. So 58 from 58 atomic number till 71 atomic number, they are not coming here. They are placed separately in the periodic table. So they are called as the F block elements. Okay. So they are always present at the bottom of the periodic table. So they are called as lanthanides. Okay. So regarding these lanthanides, they are nothing but an inner transition we study in the upcoming video. Now in time we understand in the 5D series the starting element is lanthanum, atomic number 57. Yes, after lanthanum then comes the hafnium with atomic number 72 to mercury 80. So these all elements are the third transition series or the 5D series of your transition elements. Okay. Then next comes the fourth transition series. So fourth transition series comes in the 7th period. Okay. So 7 minus 1, that gives you 6. So the series name is 6D series. 6D series. Okay. So here 6D series element starts from actinium 89. Then after 89 there is a breakup. Then it jumps into rutherfordium. Rutherfordium atomic number is 104. So rutherfordium is also called as curchitovium. That is another name for rutherfordium, curchitovium. Okay. So rutherfordium, from rutherfordium to copernicium, 112. So these many elements comes under the fourth transition series. So from after actinium, then comes a rutherfordium with 104 atomic number. From rutherfordium up to 112 copernicium. So these all elements comes under the fourth transition series. Okay, so they are also called as 6D series. Now by looking into the properties, these transition elements, they are transition metals. That means they exhibit the metallic properties. So what are these metallic properties exhibited by these transition elements? Of course, their malleability. That means they can be beat and made into thin sheets. Okay, so that is nothing but a malleability character of the transition metal. And they are also ductility. Yes, they can also be ductile. So ductility means they can be made into thin wires, long thin wires they can be made. So that is nothing but your ductility property of these transition elements. And these transition elements, they are having high conductivity, electrical conductivity as well as the thermal conductivity. So high values of electrical and thermal conductivity is exhibited in these transition elements. And they are also having good strength, they are hard, they are having good tensile strength, that mechanically they are having good tensile strength. Okay, they are generally hard metals. Transition metals are generally hard metals. Okay, so in this transition elements, you should know the names of the elements in the transition elements. So it's very simple to learn the names of these transition elements. So scandium to zinc, yttrium to cadmium, lanthanum to lanthanum, and then hafnium to mercury, then actinium, and rutherfordium, from rutherfordium to copernicium. Different elements are there. So these names we will see. Now let us look into the position of D block elements in the periodic table. So now looking into the periodic table here, you can see this is your S block element. This blue color is your S block element. Then this is your p block element, the green color, and the pink color, that is your group number 3 to 12, that is your d block elements, and the bottom part of the periodic table, that is your f block elements. Now we will study about the d block elements. So d block elements, starting group is third group till 12th group. Okay, so these d block elements, they are called as transition elements. Okay, so when we look into the period wise, the 4th period, 5th period, 6th period, 7th period. So from the 4th period till 7th period is your d block element, that is your transition series elements. Okay, yes. Now 4th period, these are also called as 3D series. 5th period, they are called as the 4D series, and 6th period, they are called as the 5D series, and the 7th period, they are called as the 6D series. Okay, now let us look into the elements here. So here the 4th period, that is your 3D series. 3D series starting from scandium up to zinc. So we'll see what are those elements here. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Okay, so that is your 3D series. Now looking into the 4D series. Yttrium, zirconium, niobium, molybdenum, tectinium, ruthenium, rhodium, palladium, silver, cadmium. Okay, so that is your 4D series. Okay, now looking into the 5th D series, starting from lanthanum. So after lanthanum, atomic number 57, then comes hafnium with atomic number 72. So after lanthanum comes your cerium. Okay, so this cerium up to lutetium, this comes under the F block elements. Okay, so we need not bother about that in F block elements, we'll see it later on. Now here we will just bother about after lanthanum, then comes the hafnium, atomic number 72, and 72, then tantalum 73, then W tungsten, rhenium Re, osmium Os, iridium Ir, platinum Pt, gold Au, mercury Hg. So these all are your 5D series. Okay, now looking into the 6D series here. 6D series starting from actinium with atomic number 89, and after 89, that is actinium, then next element is thorium. So from thorium up to thorium, palladium, uranium, like that it goes up to lawrencium, atomic number 103. Okay, so these elements are not placed here, they are separately placed. So they are F block elements, inner transition elements. Okay, so this we are not going to consider. Now after actinium, then comes the rutherfordium, 104 atomic number. From rutherfordium, again it is dubnium, seaborgium, borium, hassium, meltnerium, darmstadtium, roentgenium, copernicium. So these all are your 6D series elements. Okay, yes. So actinium, after actinium is the rutherfordium. Then from rutherfordium to copernicium, all these elements are your 6D series elements. Okay, so that's it all about your position of D block elements in the periodic table. Fine.